Okay, using matrices A and B, simplify questions 1 and 2. They give you a matrix and name it A, and another matrix and name it B. Then they tell you to find A plus 5B. That means they want you to first multiply matrix B by 5. So what I'm going to do is I'm going to move matrix B up here, and I'm going to multiply it by 5. So Vincent, what will that make this become? Right? What will this become? Right? And then these two will both be -5. Now that we've taken care of multiplying matrix B by 5, we're ready to just add the two together.
Wait.
When you add matrices, they have to be the same. Like this one's a 2 by 2, this one's a 2 by 2. To add or subtract matrices, they have to have identical dimensions. And you add the corresponding elements. Like -2 and 10 are both in the same place of their matrix. So you add them and you get a 8, which eliminates B, because that's not an 8. No, you've probably had similar questions, but not this exact one. Okay, -3 plus 20 equals, okay, so that eliminates this one. 1 plus -5 is, okay, well that's -4 and that's -4, so that doesn't help us. -2 plus -5 is -7.
Hey, we just typed it all.
Yeah,
That's fine.
I typed it in and I got A.
Yeah, I got A.
I put it in the calculator.
I got A.
Look, I'll type it in. You must have had a typo. Look, alpha zoom. The first one's a 2 by 2. -2, -3, 1, and -2. And then you're going to add 5 times matrix B. And its elements are 2, 4, -1, and -1.
That's what I did.
8, 17, -4, -7, D.
Oh,
This has a
I got the right
-3.
answer. I just chose the wrong answer.
Okay, so you can do it by hand or you can do it with the calculator. Either one will work.
Okay, see, I got the right answer. I just chose the wrong answer.
I think I just did.
Number 3. This time they want us to multiply two matrices. You learned in Unit 1 how to do this by hand, but it's going to take a lot longer than just typing it in. First, let's check to see that they actually can be multiplied. What are the dimensions of this first matrix?
3 by 2.
3 by 2. What about this one? 2 by 2. Can they be multiplied?
Yes.
Yes. For multiplying, they don't have to be exactly the same, just the insides when you put them side by side. The outsides tell you what? Right, the dimensions of the answer. That doesn't really help us though for this particular problem because every single answer is a 3 by 2. But there could be a time where you get to one and say one of the choices is 2 by 2, you would know automatically it's wrong because it has to be a 3 by 2. Okay, so let's enter these in. Alpha zoom. First we have a 3 by 2. And then you enter in all 6 of its elements. 2, 5, -3, 5, 1 and 2. Or 1 and -2 actually. Okay, always check it for typos. Then you multiply that by your second matrix, which is a 2 by 2. Okay, and its elements are -3, 0, 6, 6, and -6. And you get 24 -30, which eliminates that one. Then the second line of elements is 39 -30, which eliminates this one. And then the last row of elements is -15, 12, which eliminates this one. So it's A. Okay? Any questions? All right, let's go to the next page.
I have a complaint.
All right, number 5. Find the inverse of each matrix if it exists. You don't have to write this down. I'm just going to quickly show you this. Back when I first first taught how to find the inverse of a matrix, we learned it by hand. The formula is 1 over the determinant. The determinant is A times D minus B times C. So you would have had to have done 7 times 1 is 7, 2 minus 0 is 2, and that would have been 7. Then you would have multiplied it by the crazy matrix, which is where you flip-flop the A and the D. B and C stay, they just change signs. So like for this particular one, 7 and 1 would have flip-flopped. 2 and 0 would have just changed signs, which with 0, you don't really have to change the sign. Then at that point, you would have multiplied each of these numbers by 1/7, and that's how you would get your final answer. But it's much faster just to do it in the calculator.
Wait, what about that 1 over 80?
You don't have to worry about it. Okay, the calculator will do all of this for you. Okay, so watch. All you do is you type in your matrix first. So alpha zoom, 2 by 2. Type in the 4 elements. Okay, and then by hitting this one button right here, see below math, that button that says x to the negative 1, you hit it, and that one button does all of that for you. It does 1 over the determinant times that crazy matrix and gives you your answer. Now, a problem we kind of run into, which really isn't that big of a problem, is that these are decimals instead of fractions. However, for this particular question, 0, 1, the only matrix that has 0, 1 on the bottom is D. Now, if you want to change it over to fraction, look. Math, fraction. You just hit enter, and then enter one more time, and there it is, that's fractions. Math, fraction, and then enter. Okay,
Wait, no, I didn't get anything.
okay, look. Math, fraction. If you want to change it to a decimal, you would hit number 2. Okay, now, so we end up with this. Well, look, by hand, what's 1/7 times 1? 1/7. What's 1/7 times negative 2? Negative 2/7. What's 1/7 times 0? 0. And what's 1/7 times 7? 1. But by hand takes a little while longer, so you better just remember to type it in and then raise it to the negative 1. Okay, number 7. To solve the system using matrices, the first thing that we need to do is set up a matrix for all of the coefficients and a matrix for all of the constants. Okay, so what do you think are going to be the elements on the top line?
-2, -5,
Right, does everybody see where we got those numbers? -2, -5, +1. So what's the next line of elements?
4, 3, -6.
Right, and the last line?
-4, -2.
Okay, and then over here in the constant matrix, -19, -21, -4. Now, to find your answer, which is going to be your x, y, and z for the problem, you take this matrix, type it in, and take the inverse of it, and then multiply it by this matrix. So go ahead and take a minute, type that in. What'd you get?
139. Wait, what did I do? Oh, crap. I forgot to do the little thing.
You forgot to take the inverse of it. Okay, so what'd y'all get when you type this in, the inverse of this matrix times this matrix? Didn't know why to type it in?
I mean, I did. I just forgot to do the thing, so.
It's D. Guys, B could never work. We need an x value, a y value, and a z value. There's only 2 elements there, so B is out of the question. Now, what that means is that x is 0, y is 5, and z is 6. So look, if I go up to these equations and I replace all 3 of the x's with 0, what's -2 times 0? So it cancels, right? What's 4 times 0? So it cancels. -4 times 0. So that cancels. All of the x terms cancel out because it was 0. Now when I go over to the y's and replace them all with 5, what's -5 times 5? Right? What's 3 times 5? And what's -2 times 5? Okay, now I'm going to go and I'm going to replace each of the z's with a 6. So this is just a 1z, so just replace it with a 6. What does this become? Right? And what does this become? Okay, now let's check it to see that it makes sense. Negative 25 plus 6. What does that equal? Negative 19. So it worked. 15 minus 36. Is that really negative 21? And it's negative 10 plus 6, negative 4. So that's another way you could do it. If you didn't remember how to set it up as a matrix equation, you could just go through, substitute this for x, that for y, that for z, see if it gives you those. If it doesn't, move on. Or you might want to start one equation at a time. Like plug in negative 3 there, 4 there, 0 there. If it's not negative 19, there's no need to even try the other two. Move to the next one. Does that make sense? That's not what you, I don't know what you did there. Okay, moving on to number 9. Miss J thought of a number. She cubed the number and subtracted the original number from that result. She then divided the difference by 2. What function represents Miss J's number? C, right. Which two are like obviously wrong? Right. A is squared. We're supposed to be cubing it. Did they ever say anything about subtracting 2? No, divided by 2. So these are automatically out. These are very similar. It's just got the numerator flip-flop. But after I thought of a number, I immediately cubed the number, right? So that number gets cubed. This number doesn't. Okay, number 11.
So lame for this.
Number 11. Find the inverse of each function. There are 2 steps to find an inverse. Step 1, switch x and y. Step 2, solve for y. Okay, so the first thing I have to do to find the inverse of a function is switch the x and the y. Well, if I look up here at this function, where is the y? F of x is the same thing, so just cover it up with a y. Now when I switch those, what will the function look like? X equals 2y plus 1. Now when I start solving for y, what do I do first? Minus the 1. It'll cancel over here, and over here I now have x minus 1 equals 2y. Divide by 2, divide by 2. So you end up with y equals x minus 1 over 2, which is 8. Look at this, guys. Plus 1 minus 1 times 2 divided by 2. Because it was f of x instead of y. And we just wrote a y over it. But then in the answer, the reason it says negative 1 is because it's the inverse. Remember with matrices, to find the inverse, we raise it to the negative 1?
So basically what you're saying is just, you can just look at the problem.
For the most part. There are some functions that when you do their inverse, it's not that easy. But these...
What about 12? Is it B? No.
We'll do that one later. I don't want to do it yet. Okay, number 13. Perform the indicated operation. Okay, you have 2 different functions, and they want you to do g of h of 5. Okay, well, what is the 5 currently sitting with? The h. 5 is with h right now. So, I'm going to go to the h function and replace it with a 5. That'll become 2 times 5 minus 2, which is 8. So now, h of 5, didn't we just learn it equals 8? So now 8 is now sitting by the g. If I go to the g function, plug in 8, 8 minus 2 is 6. Okay, next page. Number 15, describe how the graph of f of x equals x squared can be transformed into f of x equals x squared minus 6. Is it right 6, left 6, down 6, or up 6? Down. Okay, let's talk about that. Okay, if you have x squared minus 6, that's down 6. If you have x squared plus 6, that's up 6. Those are what we call the outside numbers. Negative 6 and positive 6 are outside. They go up and down. Minus is down, positive is up. If suddenly the 6 is on the inside of the parentheses with the x, that shifts it left and right. And it's the opposite of what you would think. Minus is actually right 6, and plus is actually left 6. Okay? Now, if you get to the test and you're like, I just can't remember, what could you do? Graph it. If you go to the calculator and you graph y equals x squared and y equals x squared minus 6, the graph will show you what it does. There's the first one. There's the second one. 6 down. Okay? Number 17. The square root of negative 64. What happens when you type in the square root of a negative number? It gives you an error because it's a complex number. What's the square root of just 64? And anytime you have a negative, what happens? I. So D. Think about it. The reason it can't be negative 8 is because negative 8 times negative 8 is positive 64. And this is a negative 64. But 8i times 8i is 64i squared. And what's I squared equal? Negative 1, which makes that a negative 64. Okay, number 19. What would you do on this one? FOIL. 6 times 5 is 30. 6 times 5i is 30i. 8i times 5 is 40i. And 8i times 5i is 40i squared. Well, can't the 30i and the 40i combine to what? 70i. What's I squared equal? And so that makes the 40 a negative 40, and 30 minus 40 is negative 10, which is B. Right. Okay, let me show you something else that you'll like. Parenthesis, 6 plus 8i. See where the I is down here on the decimal? You just have to hit second before pressing it. And then 5 plus 5i equals negative 10 plus 70i. You just type it in. Okay, number 21. Find the conjugate of 6 minus 3i. When it asks for the conjugate, what do you do? Not everything. Of the complex number. So it's D. You don't touch the real number. You only change the 3i to positive 3i. So like if you had negative 3 plus 6i, what would the conjugate be? Negative 3 minus 6i. You only change the sign of the complex part. The real part stays what it is. Okay, next page. Simplify each expression. Well, what method are they wanting you to use to simplify it? Look at it again. What sign's in the middle? Subtraction. Anytime you subtract and there's a bunch of stuff after it, what happens? Right, like that 3 is now going to be negative. This 3 is now going to be positive. This 8 is now positive. This 2 is now positive. That's all you do. Now all you have to do is look through it and combine the like terms. Like 7x squared and 3x squared are like terms. What did they make? Right, but that doesn't really help us. So let's move on. 2x and 2x is 4x. That helps a lot. There's only one answer with a 4x. Okay, number 25. Find each product. What does product mean? Multiply. Well, what does that mean below it when it says 2n plus 7 squared? There's 2 of those. So instead of writing the squared, we can just write it twice. Now when you see to multiply a binomial and a binomial, what method pops in your head? FOIL. 2n times 2n is 2n times 7 is 14n. 7 times 2n is, and 7 times 7 is, and then what can you do? Right, 14n and 14n is 28n, which is A. Remember, this video will be on the blog tonight. It would be wise of you to go back and watch me go over these 13 if you were confused by any of them today. Tomorrow we'll go over 13 more odd. Friday we'll go over the remaining 14 odd. Then on Monday and Tuesday we'll take a practice test. Wednesday and Thursday are the real tests.